Hello guys, and welcome to Realistic Boiling Water Reactor Simulator. This is a guide for the Unit 1, so if you are watching this guide, probably you are new to the game. So I will try to give you some hints how to start this up and how everything works. There is a gear icon on the right side of the screen. If you open it, there you may find a few helpful things like the manual, descriptions, which if are enabled will tell you what certain things do. And there is also an interactive guide which tells you step by step how to start up the reactor, so it basically does what I will describe. So I encourage you to use it, but please do it on a private server so you are not interrupted by others, because this is like just designed for one person to do step by step. And okay, so let's start. So this is the emergency core cooling system panel. We won't be using it now, it's only used in the emergencies. So we have like reactor core isolation cooling and low pressure coolant injection, two devices which are used to increase level of water in the reactor in case it dropped and we couldn't increase it in any other way. The RCAC doesn't require electricity, it uses steam, while LPCI needs electricity. So depending on the situation you might want to use one or the other one. And this is the residual heat removal panel. So you can see reactor temperature is now at 31 degrees. If we disable this pump, the temperatures should start to rise. And this is because there is some energy in the fuel, even though the reactor is not operating yet. Okay, and this is the main reactor panel. We'll use it to push and pull rods to change reactivity and reactor power. This is the auto control, we'll discuss this later. The recirculation, we'll also discuss this in a moment. Turbine, so this is where we generate electricity. This is the main cooling panel. This is where we manage how the water flows through the cooling panel. We have condenser, when the water condensates, steam condensates back to water. Deaerator, where we remove uncondensable gases, and electrical panel. So I will discuss all of this just in a moment. So how this works, it's actually pretty simple. So there is a lever. If you push it forward, you will start pulling the rods. So you can see this is the rods position. They are being pulled now. The more percent here, the more they are pulled. And this will increase reactivity. And this is like a map of the core. So you have like 24 groups. And we can individually change the rod pulled in each of the groups. Now we are moving all of them, so you can see the percentages just rise equally. But if you want to work with a single group, you can just select one or two, and then you go into this group mode, and you can work on only what you have selected. Okay. Let me go back to all. So the reactor period. So this gauge, this indicator, is the most important thing, because it tells you how quickly the reactor is gaining power, and it does it in, you may find it a bit strange manner, because it tells you in how many seconds the power of the reactor will rise by a factor of more or less 3. So if it's at infinity or on a very large number, the reactor is stable. When the number is low, the reactor will be gaining power quickly. So let's say if you are at 30 seconds, it means that in half a minute the power of the reactor will rise by 3 times, but after another half of minute it will rise by 3 times from what it has already gained. So it will be total of 9 times. Yes, almost 10 times. So if you are at 10% of power and you have this reactor period at 30 seconds, you are just a minute from full power or a disaster in a moment. But we are very low powers now, so it doesn't really matter that much. But anyway, you should never go with this below 30 seconds. We can also change the speed of how quickly the rods are pulled. If I put it to fast, you can see that they are pulled much quicker, and also immediately the period started to drop significantly. So at the early stages, when the power is really low, you can go really fast with the rods, but on higher powers you have to be very careful. Also, you need some experience to know how this works, because reactor at some stage goes into so-called criticality, and it doesn't need any more rods to be pulled, and it will be rising power despite of that. So if I stop the rods now, it's not yet critical, because you can see the period is going to infinity. It will just stop at this power level. But at some later stages, if you even stop the rods, the reactor power will still continue to rise. And also you can see that some parts, like a map of the core, some parts of the core are warmer, other are cooler. This is because of the different fuel amounts in the rods, and also the middle rods are usually hotter. So you can balance this by yourself by just selecting the rods and playing with this, or you can just enable the auto balancer. So this is the switch. It will do the work for you. You can also see the vertical display of the rod. In RBWR reactors, the rods are pulled from top to bottom, so they go out to the bottom. So this is why at this moment we are about 20% pulled. So this part has no control rod inside. This is why it's the hottest at this moment. This will of course change later. And there is no indication of actual power at this moment. For very low powers, we use this source range monitor. It doesn't really show us anything, just counts of neutrons, which is hard to relate to anything, but you can see it's rising. So that's okay. In a moment we'll switch to IPRM. Okay. So you can see I went below 30 seconds, so I have an alarm. I can acknowledge it now. It's okay. But anyway, what you want really to do is to do it on auto control, because if you don't have a lot of experience yet, you cannot really control all of this manually. So auto control is a simple panel. You just pre-select something like 5% and switch to enable. And now the auto control will take care of pulling the rods, and will also take care of keeping the period above 30 seconds. You can see it will stop pulling the rods, or will do it slower if you are nearing 30 seconds. So basically you don't have to worry about it anymore. If you want to change the set point to something like 6%, you can use this manual set point switch if it's not on the buttons here. And okay, now we are entering into IPR, intermediate power range. So how this works, you can see we have this percent gauge and also this thing here, which shows you what are the proper limits. Once we are nearing to the upper limit, which is about 75 or 80%, we should increment this. and we do it, the IPRM drops again. So this is how IPRM works. There are several levels, 6 of them for this unit, and whenever you are in the top part of this IPRM, you just increment it. So this doesn't tell you a lot about the reactor power either, but by just looking, we are level 2, so this is still pretty low. When you are level 6, it means you are already in the heat gaining region. So this will be around few percent of reactor power. So this is like another way to measure the reactor power while it's pretty low. Okay, we are now at 100 degrees. This is due to the decay heat. So the water will start to boil, and you can see this immediately here. This is the steam pressure. Steam pressure will start to rise in this moment. And once the steam pressure is rising, also the boiling point is rising, which allows the water to actually be hotter than 100 degrees. Okay. Level 4. And yeah, once we are doing this, we can continue to set up the rest of the system. So this is the recirculation panel. It has 2 pumps, the upper one, the lower one. So each pump has like 3 switches, the pump itself, the inlet and the outlet valves. So I want to enable this now. Okay, let me increment. So I start with the inlet, then the pump, then the outlet. And recirculation is another way of changing reactor power. When you increase the recirculation flow, the reactor power will rise, but this is not very efficient on very low power. So what we do now, what the procedure tells us, is to open these valves to about 28%. So I'll do it in a moment, just have to look at this. Okay, level 6, this is the last level. And once we are at level 6, in a moment we should see the power on the average power range monitor. This will give us power in the percent of maximum rated power for this unit. Okay, we'll come back to this in a moment. So let me open the valves. So you can see when I switch it to the right, it starts opening, but some of the switches have like 2 notches, so you have like 1 plus and 2 pluses. So if you open it more, it will rise much quicker. That's how we operate this. So I want to put it around 25% just for this moment. Okay, and we're done here. Okay, we are 2% of reactor power now, 2.5. Let's see how our pressure looks like. Okay, it's rising. So what can we do with this rising pressure? Because now we are not letting it out anywhere, so it will just start building until it explodes. Yes. So on the turbine panel you have this bypass valve. It's this one. If I open the bypass valve, you can see there is bypass steam flow, and this like opens a hole through which the steam goes out of the reactor. Okay, let me open it more so you can see that we can actually drop the pressure. So now the pressure is dropping because I'm taking a lot of steam. Well, and I will run this in a moment. So this steam goes directly to the condenser. Yeah, so because the water like circulates in a closed loop, so we want to reuse this water. So when we use the steam, we want to turn it back into water, and this is what is done in the condenser. So this is a diagram of the condenser. Generally, how it works. So when we have the steam which was already used, you want to cool it down. and when you cool it down, it condensates back into water. And when this happens, as the water, when steam changes into water, it contracts a lot. So this causes a kind of vacuum to create. Yeah. Okay. Anyway, so this is the pressure in the condenser. So first I want to enable these two pumps. There are electric pumps. They just reduce the pressure a little bit. And now I will enable the pump. So this is the recirculation pump for the condenser. So this pump uses like another water source, like a lake or sea or something else. It takes water from there, puts it through the condenser, the cold water, to cool down the steam, and then it goes out. So this is the only thing this pump does. And when we start opening it, you will notice that the pressure will start dropping much quicker. This is because we are starting to condensate the steam. And also, so I'll put it at 25% for now. And also, we have these steam jet air ejectors, because there are some gases dissolved in the water and we cannot like use them, we don't want them. So this is what is this device used for. It's used to just eject those gases. We just use one, we can open it at 100%. And what I will do now, I will just put auto control on. Auto control will manage this valve for me to keep the desired pressure, which is between 40 and 70 millibars. So you can see this here. So this is the region we are aiming at, and this is a zoom in. And the proper vacuum level is required to run up the turbine. Okay, we'll come back to this in a moment. So what happens now when the steam is condensated back into water? It gathers in hot well. It's the lower part of the condenser. So this is why I will come to the cooling panel now. And yeah, let me enable it. So cooling panel. So what happens to the water? It has to be pumped back into the reactor. Yes, that's obvious. So the circuit completes, but we also in between. So this is the hot well. Somewhere in between we have a deaerator. Okay. Yeah. So there is like another device. Before we pump the water into the core, we put it to the deaerator. The deaerator is used to eject the uncondensable gases which were left by the condenser, and only after the deaerator we pump it into the reactor. So this is, you can see the total steam flow. So this is the steam that we take from the reactor. We can change it with the bypass. If we open the bypass, you can see the steam flow rises. But it also depends on how much water we actually boil, so it depends a lot on the reactor power. And this water gathers in the hot well. And if we want to pump this water further, we need to enable this condensate pump, and we want to increase the flow. So you can see this is the amount of steam that is changing into water, and this is the amount of water that we are taking away from the hot well. So basically we want these two to be similar, because this guarantees us that the level in the hot well remains constant. Now we have a lot of water in the hot well, actually too much. So maybe we should open this more, but let me just keep it at similar level for a moment. And now you can see the level in the deaerator rises. So again, we have to take water from the deaerator back into the reactor, which is actually pretty low now. I have an alarm on that. So we use this is called the Feedwater pump. So let me rise this. Yeah, I know. So when I rise this, so this is the outflow from the deaerator into the reactor. Now, because the outflow is larger than the inflow, so obviously the level in the deaerator drops. And basically that's how it works. So this hot well level is still very high. I want to increase the outflow from hot well. So basically 0 is the desired level. Anything above is just too much. Anything below is not enough. So if I want to keep this level, for example the deaerator, you see it's dropping, it's because I'm still taking more water than I'm giving. I will use the condenser pump to increase this above what I'm taking. This way the level of the deaerator should start to rise. The reactor level will also rise because I'm pumping more water than it's actually turning into steam. So this is how you can manage this. In the meantime, I will enable the preheaters. Preheaters are used to heat the water coming into the reactor. Also one polisher should be always on. This is the last thing I want to set up just in a moment. Why cannot? Okay, I pressed the wrong button. Okay, so you see these levels are pretty fine. We have a little too much of the water in the system, but let me just now balance the flows more or less. Okay. So once you have the flows balanced, you don't have to do it very precisely, just more or less like that. So it's guaranteed that these three levels will stay the same. Yes, because what is coming in is coming out, coming in, coming out, yeah, at the same amount, so these levels cannot change. And if you have too much water in the hot well like I have now, you can use this hot well drain. It will just take out the water from hot well into the condensate storage tank. So this is the level of the tank. It stores the water for you to use it later. If you have not enough water, you can use this other hot well makeup valve to put it back. So this is how you can, okay, switch this off. But anyway, I will put this now into auto control. So the auto control will manage, change the flows. Here are the set points. So everything is set at 0. If you want, for example, to have 1 meter in the hot well, why not? You can put the set point here. It's just 1 meter above the optimum. If you for some reason want to have more water in the system, no problem. The auto control should manage to do it just in a moment by changing the valves here. Okay, so I already told you about the deaerator. It's here. So how does the deaerator works? The idea is to so we have like a water in it, like coming through the deaerator, and you want to heat up the water with steam so it boils, and when it boils it's easy to eject the uncondensable gases. So there is another panel here just for the temperature of the deaerator. So you have here is the level. You cannot like change it from this panel, but what you can do, you can change the temperature and pressure. So you have two valves, inlet and outlet. If you start opening the inlet, so you can see I'm now pumping some steam, not a lot really, but can see the temperature is rising and also the pressure is rising. So in order to keep the pressure in some limits, I want to open the outlet a lot, over the 50% at least. So the pressure shouldn't go above 1.6 bars. And the optimal temperature is 108 degrees. Oh, here is the temperature gauge. Okay. So once it's set up, you don't really need to care about it a lot until you change the power of the reactor, because this will affect the amount of steam and will change the temperature. Okay, at this moment we are just too cold yet. Even at 100% I cannot rise the temperature to 108 degrees, so I'll just leave it for now. Okay, we are basically set up. So now let me increase the reactor power to 10%. So this is the minimum for the turbine run-up. So let's see, it started pulling the rods a little bit, and the power is rising here. And on the turbine panel, we have already built some pressure. You see the bypass is at 60%. This is a pretty good setting, because the 5,000 kilopascals, so 5 megapascals is around the minimum that we want. The top is 7.1 megapascals, 7,100. This is the optimal pressure which we want in the system. So if I want to build the pressure a little bit faster, let me close the bypass maybe by 10%. You can see the pressure started rising a little quicker. Let me confirm I have vacuum. Yes, 54 millibars, so it's just in the middle of the range. The auto control is doing a good job. And let me see. So you remember the set points, 1 meter for hot well, 0 and 0. So it's almost there. Hot well might have... Okay, I was just changing the steam flow, maybe that's why the auto control didn't manage to do it perfectly, but it's pretty good. And how is our reactor power? Almost 10%, like we wanted. You can see that the balancer really did a great job. All the groups have almost identical power at this moment. So actually I can switch it off now. And you can see with the rods pulled to about, well, different groups have different rods pulled distance, because the core usually heats up quicker, but also different groups can have different amount of fuel. So yeah, this is how it looks like. So you can see with this amount pulled, the top region is now the hottest. If you select a single rod here, for example, let's pick a rod that's pulled. This one is pulled almost to 50%. If you select it, I will see a cross section for only this one rod. If I select a different one, I can have a little different profile, but it's not that much. You can also look at different slices of the core. So now we are looking at average, but if we use this, this is the top level of the core. So you can see at the top, this rod is the hottest. And you can go lower and lower, up down to the bottom. So this will be level 10. So this is the bottom of the core. At the bottom, the center of the core is the hottest. Interesting. This doesn't really matter for us a lot. Okay. So once I increase the power, you can see now we are already above the desired temperature for the Deaerator. So let me just drop it a bit. 108 is our optimum. If you are in doubt, you can just look here. And if it's blinking slower, it means that the condition is no longer in force, but you still need to acknowledge it. have a phone. Okay, so the grid control tells us that we have a demand. Yeah, we'll do this in a moment. We have to like start up the turbine first. Okay, so condenser vacuum is here. Everything looks perfect. 10% of reactor power. Let's start turbine. Okay, the pressure is almost ideal. We want it at about 7,000. So how do I start the turbine? I enable this turbine valve, and now I open the valve. As you can see, I'm opening the valve, the turbine RPM is started to rise. Now we are losing pressure, so I'll just close the bypass. We don't really need it anymore because it's just wasting steam. And now the bypass steam flow will be changed into turbine steam flow. So now we are directing steam through the turbine. You see the pressure is rising pretty quickly now as I close the bypass, so let me open the turbine valve more. This is important, you want to control the pressure here. And once you open the turbine valve more, the turbine accelerates quicker. If in any case this pressure would rise too high, okay, I'm like speeding up the turbine too quickly, so it's vibrating, but this doesn't really matter in unit 1 because it won't treat the turbine. In unit 2 you will have to be more careful. In any case, this pressure is too high, you can always open the relief to get rid of the pressure, but be careful because this will also lower the level in the reactor, so in emergencies this could be dangerous. And our goal is to synchronize the turbine at 3600 RPM, so it's 3600 RPM. So this is the network frequency, 60 Hz. So how do we do it? We just need to, obviously now we are accelerating. If you want to slow down this acceleration, you need to close this valve a little bit. So you see now we are accelerating slower, you can stop it. But now the pressure started to rise again, so yeah, you have to be careful. If you want to close the turbine valve and not rise the pressure, you might want to use the bypass a little bit. But generally, if you do it on 10% of reactor power, this should be almost ideally set up for you. If you are more experienced, you can do it on 15% or even 20%, but then you will have to rely a lot on the bypass to synchronize it. So our goal is to reach 3600 RPM, and then we want to stop there. Once you are an operator, so you have a higher rank, you will also have to use the synchroscope correctly. So you want to synchronize when the synchroscope is pointing top, more or less. But when you are new to the experience, it's not required. You can do it without the synchroscope, and I really encourage you to do it manually because this is probably one of the first things which you should learn to do manually, to synchronize the turbine. But if you really give up, you can use the auto control here too. You can just select 3600 and enable, and it will do it for you. But I want to show you how to do it manually, so I'm looking at the RPM, looking at the pressure. You see now at this RPM it's taking a lot of steam and the pressure actually started to drop. So if for some reason I cannot reach my goal, the pressure is dropping too quickly, I need to increase the power just a little. Now the pressure is still pretty high, so let me open this just a little more. Okay, so I'm very close. I will close the valve just a little, or maybe not, just a little. See, you want to do a very short impulse, like this, almost stop. Yeah, almost there. And this is actually where I can already synchronize. If you want to play with the synchroscope, it's also pretty good. And now it's synced. Okay, I immediately got reverse power. When this happens, just open the valve a little bit. Acknowledge. Okay, I'm synchronized. So now the pressure is just a little too low. Let me just now raise the power to 20%, and again reverse power. Doesn't matter because I'm raising the power now. And so this is the load. This is what I'm producing, 33 megawatts, and our plant is using 35. This is, oh no, sorry, 24. Okay. So the difference is sent to the network. So this is what I'm sending to the network now. And again, started rising power causes this to shout on me. So I want to probably below 108. Because I'll still be rising power. Okay, anyway. So now, what changes? When you are synced, the RPM no longer change. They stay as they are. But you can still continue to change the pressure with the turbine valve. You see the pressure is rising, so I want to open the turbine valve more. And now you can see that when I do it, the RPM stays, but the generator load increases. So now I'm producing more power. Just the steam is used to produce more power. So whenever power is rising, like now 20, okay, let's move to 30%. So whenever the power is rising like that, the pressure will rise, and you need to open the valve a little more. You can see again pressure started rising, we are producing even more power, and of course if you are going down with the power, you will have to start closing the valve to keep the pressure at around this limit. But again, you probably don't want to do it. You can now enable the auto control for the pressure. Auto pressure hold, if you switch it on, it will work with this valve automatically to keep desired pressure. Okay, what's that? New demand is one. It's pretty high demand. It's almost like 90% of reactor power. So basically that's what we are going to do now. So this is where you can see the demand. You want to send to the network over 1 gigawatt of power. Now we are just doing 20% of that. Actually you have to know, more or less, this reactor at full power gives you 1200. So to get something like this, you need around 85% power. So that's what I want to do now. Of course, the Deaerator is set up. But before we do it, there's one more thing we have to learn about the electrical panel. So as you can see, I didn't enable those pumps. This one is blinking red. Also this one is blinking red. And this one is blinking red. This is because they are unpowered. You cannot power them before you synchronize the turbine. So let's have a look at the electrical panel. It might be a bit confusing at first, but it's actually pretty simple. So the top line, this is the offsite line. Yes, this is the outside external power line. And this is the main bus. This is the bus which powers all our main pumps number 1. So all the pumps that we used. Yes, the top ones. This one, this one, this one, this one, and also powers both of those. So if you look at it, you can see what is actually powered at this moment. You can see that also hot wheel drain makeup. These are all powered from this bus. And now we are being powered from the offsite by this startup transformer. So you cannot start the plant if you don't have power for the pumps. We need the outside power to do it. That's what we did. Okay, and this is the B bus. So the B bus cannot be powered by offset. So the B bus is responsible for this pump, this pump, this pump, and this pump. We want these pumps because for higher powers, one pump is not enough. So you can see that both of these buses can be powered from here. This is our turbine generator. So we are now producing power and it is being sent to the network, to the offsite. This breaker is the synchronized switch. This is exactly the same switch which I used to synchronize turbine. So now we are synchronized. You can see this is green. We are sending power to the network, but we can also use our own power to power both buses. So let me do it. If I do it, the lights will blink. Okay. And now I am disconnected from the startup transformer. Now I'm powering bus A with my own energy, and I can also power up the bus B. And now I can, these pumps will no longer blink. Oh, sorry. It's no longer blinking. I can enable this. And now I can use the full power of the reactor. That's just to confirm. Oh, condenser, circulation pump. I forgot this one. Okay. So just to confirm, all important pumps are powered. Yeah, we are good to go. But before we do that, I will just quickly describe the rest of the system. So you can see, so these buses are high power. They are like 60 kilovolts. This is really high voltage. Then we have a transformer which is connected to the bus A, and with this switch, this one, we are powering our safety bus. This is called bus safety. It's lower voltage, only 480 volts. And this is used mostly for the safety equipment. That's what I told you, LPCI, so low pressure coolant injection, shutdown cooling pumps. So these three are powered by the safety bus. Also some other stuff like these two electrical pumps we used, they are also powered from the safety bus. Okay. And this bus, what is interesting, can also be powered by the diesel generator. We have a diesel generator here. So once we start it up, we can connect it to the bus. So in case we lost the power here, we still, with the diesel, should have access to our safety equipment here. Okay. And what next? We have also these two DC buses, so these are direct current buses. So from this bus, via this switch and the rectifier, which is not shown, okay, it's AC/DC, we can power this so-called DC bus. It's 125 volts of DC current. It's mostly for the lights and ventilation. So just to show you, if I switch it off, the light goes off, and we get this emergency lights. Of course, there's an alarm, knowledge. And yeah, if you don't know the panel, it's not so easy to know what to do, or where is the we have some flashlights here, but I don't remember where. Okay. Okay, I didn't want to press this one, but it worked. Okay, here is a flashlight. Maybe it's good to have one with you, just in case. Okay, let me switch this back, how it was. So, yeah, so this can also be powered by the diesel, yes? By powering this bus, you can power this one. And also, this bus is used for the startup to the diesel generator. The diesel generator needs electricity for startup, so you can use this switch to provide this electricity. So this bus has to be powered, and then you can start the diesel. You can see the RPM will rise. Once it reaches 1800 RPMs, it can be used to power the safety bus. I won't be doing this now, just to show you. And the last bus, the red one, this is the emergency bus. And this bus is used basically power the panels, and it gives us this this emergency low power lights. So and this is powered by, normally it's powered again from the safety bus via this rectifier switch, but if you turn it off, it still stays on because it has a battery here, so it never goes off. You can see this is the battery. It will drop with time. If it goes to zero, the game's over, because at this moment you basically lose control to the panels and you cannot do anything. So yeah, never do this. And of course you can also power this if, for example, you lost power and you have to start up the diesel. You can power this DC bus from the emergency. You can use this switch to do it. So now even if I disable power to this bus, we are still powered from the battery. We still can start the diesel generator. That's how it works. Okay, nothing more. Okay. Okay, so this is okay. Temperature a bit too low, but we'll be going now up. Yeah, so we had, okay, there's new demand coming. It's almost the same, 1000 megawatts. Yes, I know. Okay, and as you remember what I told you, at higher powers, we want to use recirculation instead. So what's so let me disable the auto control for a moment. So you can see if I don't move the rods at all, the reactor is pretty stable. Actually, it's rising power just a little. This is probably because we are burning xenon now, which is very high. Well, maybe not very, but it's pretty high. But generally the reactor should be quite stable. So now let me increase the recirculation. If you do it, you can see that immediately power started to rise, the period drop. So this is another mean to control the reactor. You can use the recirculation. Usually you do it above about 30, maybe 40%. So you can use the rods to reach the 30, 35, maybe 40%, may depend on some conditions, and then you switch to recirculation. And can you do it with auto control? Yes, you can do it. So as I said, we need about 85% of power. This is just a rough estimate. You don't really need to know exactly, because you will like correct it later. And now I don't want to move the rods. I want to auto control to use the recirc. So this is how I do it. I switch to recirculation mode. And now when I enable auto control, you will see that the computer will now use the recirculation to reach the desired power. So the power is rising, so the pressure would be rising, but the auto control will be opening the valve, turbine valve, to, you can see, to keep the pressure constant, and this will cause the generator load to rise. And our site is using about, you see, 60 megawatts. So actually we need to, and this is rising because these pumps use a lot of power. So we will want to reach a little higher output than 1000, probably something like 1080. We will see this in a moment. Okay, let me now set up the Deaerator just a little. I will keep it lower for a moment because it will rise anyway. You can see that so the amount of steam is now much larger than before. So the one pump is no longer enough. You have to use two pumps here, and also you need two pumps here. If you are over 50% on the condensate pump, you need to have both, because if you disable one, you have only 50% of output maximum. So you can see the auto control is increasing both flows to match with this one. And also in the condenser, this is at 70%, you can see already, because if you are pumping a lot of steam to the condenser, you also need a lot of cooling, or the pressure would just rise, and this would trip the turbine. Okay, so we are at what I set up, 85% more or less. Let's see, still some space to even rise the power more, because we are not yet at 100%. So we are sending to the network not enough, obviously. We can check it here. We are minus 71 below. So the demand is 1000, we are sending only this. We need 70 more megawatts. So let's increase this by a few percent. Let's make it 88. Let's see what happens. So again, the power is rising here. The load is rising. Okay, we are already plus minus 50. This is what you need. So once the demand is fulfilled, you can see that my score should rise. Perfect. Okay, this is still a little below, so probably 90% is the correct setting. So you see, I don't know the exact values, it's always a matter of experimenting. And now we will burn xenon as crazy, this will increase. I just don't want to go a lot into detail, since this is the moment where we want to finally set up the Deaerator. Okay, this is perfect. So yeah, 2 megawatts below, we are perfectly in the right place. Let's have a look at the annunciators. Nothing, this is only automatic control. I think we are missing the automatic control annunciator for the condensate. I will have to probably put it. Yeah, and this is how it works. That's basically all of everything. So you can see the auto control is really managing this a lot. The only thing that I really need to do is to change the power and then to set up the Deaerator correctly to have it all working. So now just a few more things about malfunctions. So by default they are on. I just disabled them for the sake of the of this manual. So several devices can break down. What actually can break down? recirculation pumps, feedwater pumps, condensate pumps, preheaters, condenser recirculation pumps, and steam jet air ejectors. So I won't be going a lot into details now. If you want, probably you can read about it here or in the manual, how to deal with the malfunctions. Generally, it's quite logical. For example, you can read the flows. So if the if the settings are similar here, we expect similar flows here. Yeah? Now it's okay. But if you see that one of the pumps has much lower flow, even though it has the same setting, it means it's malfunctioning. So basically, that's the idea. For the preheaters, you want to check the feedwater temperature. If you disable one, the temperature drops. You can disable another one. If it drops by the same, they are okay. They are working to the same extent. And you can also experiment with the other pumps. It's pretty fun. It gives you points. So when this happens, when you find a malfunction, you have to disable the device, tag it like that, and then you call the technician to repair it. But for example, at this moment when we are doing this 90% of power, I cannot disable any of these pumps. So this is a little bit a matter of strategy. For example, you can ask yourself, can we still work with this malfunctioning pump? Because it's still working, it's just giving us less flow and we need, no, but we can still use the other pump. So can we do it? Because the demands are heavily reliant on the time. So in the middle of the day, the demands are the highest. But now we are actually, it's an afternoon. Next demand, which comes in a few minutes, will be probably lower. And if the demand is lower, you probably will be able to disable one of the pumps to repair them. So often it's a matter of strategy and it's just planning ahead. And also, some events can happen. One of the events is shutdown for maintenance. It's just shutdown, you just stop the reactor. So I don't want to go into details a lot about it. You can just shut it down, turn off everything and enable the cooling pumps, and you will have to cool it and it's done. And you can also have this offsite event, when you lose offsite power. And so basically there are two types of this event. It can be announced or not announced. If it's announced, you can try to go in so-called islanding mode, in which you can power yourself, but you have to prepare it. So I can show it to you how it works. So basically you want to go to 10% of power, maybe a little more, let's say 13. And what you want to do is to match your generator load with your facility power usage. And when you do that, you can desynchronize from the network and you can continue working by yourself. If you tried to do it now, when you are doing this very high generator load, it will trip the turbine. If it didn't trip the turbine without a proper load would just spin up quickly and dissolve itself. So this is why you want to match what you produce to what you consume, because this will help you to keep the turbine at a constant RPM. Okay, once we get below the 30% here, we actually want to switch back to rod control. And I will help it a bit, do it quicker. So we have 35% now of power. So when there is this announced offsite disconnection, you have few minutes to prepare. So this is basically what you want to do. You want to reduce your power immediately. And let's see how our load looks like. It's still above 100 megawatts, so it's too much. You can use bypass to like kill it quicker. Okay, let me do this on manual. So I will open bypass just a little for now. Now the pressure is dropping due to bypass. I will close the turbine. You don't want to close it too much, because if you go at the negatives you can trip the turbine. So what is our okay. Send to grid, still sending 18. Okay, I won't be talking with them. So we want to have around 20 here. Okay, it's already not enough. So something changed. Okay, I just didn't read it correctly. We're almost at the spot. So now, before I do it, I should actually tell the grid control, so they are not angry. Okay, it's approved. And what I do now is I just desync. Now you can see turbine RPM changed. It's a little below. It means we were just below the right power, but generally I'm okay. Maybe okay. I need to close the bypass. I just open it. Now once I close the bypass, this should just stabilize. And now I am basically powering myself. So you can see I'm disconnected from the offsite. So I'm just being powered by my own generator. But this can work only if you match the load with the facility usage correctly. If you don't do it, the turbine RPM will just run away, either down or up. So this is so-called islanding mode, and you can do this when the offsite event, offsite disconnection event is announced. And once it ends, you just synchronize back to the grid. So I'll do it now. See, I'm doing very quick adjustments, very short, like okay, let me put this on auto control. Let's go to some higher power, say 50%. Okay, it's no longer active. Now I want to show you what happens if you get a surprised offsite power loss. So basically, when you lose the offsite power, so when you lose this line, what happens? The generator is producing a lot of energy, and this energy has nowhere to go because this is cut. So it just cannot work. It has to trip and disconnect because it would just spin up if it's because there was no load on it. And when this happens, you lose everything. Basically, all gets dark. So the first thing which you want to do is to power your DC bus, so the lights and the ventilation from the emergency bus. So this is the first thing you do, because then you get the lights back at least. And once you have lights back, you have no power to any of this, so you don't have any pumps, and the water is still boiling in the reactor. Then you will have to use this core isolation cooling. Yes. So you want to use the steam to drive a pump which will put water into your core. So that's what you do. And in meantime, you want to start the diesel generator, so you can later on use the offline cooling to basically cool down the reactor, and if you need, you can use the LPC, low pressure core injection too. Okay, so let's do it. Just to show you, we are on a 50% power. Everything is more or less set up. I'm totally surprised. Okay, this is what happens. It's getting dark. You see, everything is red except for this part. So you want this to get this light. I will start the diesel generator. So this is the spark and this is the starter. I have to wait. I have to scram the reactor now, because it cannot work. And now, you see, we are already very low on the reactor level. So I will just start this. Open the inlet valve to maximum. And this is very scary. But this pump takes some time before it spins up. And the level is still dropping. This is actually, if you don't do it correctly, you can actually melt the core. Is it still dropping? It's -5. But more or less it stabilizes now. So you see, this pump, it takes time before it really goes to maximum power, but now we are back to rising reactor level. So it's okay, we are safe. So the pressure is dropping slowly. Don't use the relief now, because if you do it, you lose the reactor level. You also have a relief here for the core isolation cooling, but for the moment I usually don't use it until I have diesel. It takes a while before it starts. Also remember to check the battery. Oh, okay, it's enabled by itself actually. But it's unpowered, so it won't help. So we need diesel to run this. Yeah. Okay, diesel is now on. So now I will power the safety bus from the diesel. And this enables low pressure core injection. It works below 3000 kilopascals, so it's okay. Rise the level here quickly. I will start offline cooling pumps too, because when you have like this offsite event, you want to cool down the core. It will take a couple of minutes because the temperature is still pretty high. And don't forget, once you have this bus powered, you want to power this bus, DC bus, from safety bus, so you don't use the battery. Yeah? So you want to do this. And that's basically it. It's gonna be stable now. Once we are at about 0 reactor level, I can disable this core injection. You can start the relief now. It will drop the pressure quicker, which will drop the temperature. Now it's safe because I have low pressure coolant injection available. So that's how you do it. It's really it happens to you for the first time. It's gonna be scary as hell. I got scared myself. So when it happens by surprise, so remember that the priority is to get the lights back, start the diesel, and enable this reactor core isolation cooling to provide water to the reactor, which is still boiling. Of course, scram the reactor to 0 if it doesn't scram by itself. Okay, I really covered, I think, almost everything. Was I hope it was fun to you. As I said, do this guide. It will really help you for the first time you start the game. And yeah, have fun. If you manage to get to this moment, congratulations. So see you guys another time.